Okay, let's go to page 15, and this is section 2.2. This section is on graphing trigonometric functions, and the way that it started out is that let's go and use the sine function first. Sine function is easier to correlate and easier to see how it correlates. Okay. So basically what you do is you instead of looking at the circle, you're looking at the x and y. Okay. So we're going to look at graph of sine theta. Okay. So remember sine, we're using unit circle, right? So sine is vertical. So at 0 degree, the height is 0, right? And I'm going to and so at 30 degrees, right over here, at 30 degrees, so this would be you just transfer this over, right? So at 30 degrees, it would be right over here. So I'm making every hash mark equal to 15 degrees, okay? At 45 degrees, again, you just transfer this over, so it'll be right over here. At 60 degrees, you just go over like this. It's going to be right over here. And at 90 degrees, right over here. And if you connect all the dots, it's going to look like this, okay? And then the next value, okay, at 120 degrees, is going to go down. Okay, so it's going to go down to here, and then it's going to go down here, and it's going to go down. So when it's at 180 degrees, it's going to go down to here. So graph is going to go down like this. Okay. So if you do a complete cycle, the sine graph is going to look like so if you continue follow around the circle, it's going to look something like this. Okay. And you can also go backward. Okay, so this would be the sine graph. So this is just one quadrant. So this is just one half of the circle. Okay, so from here to here is quadrant 1, from here to here is quadrant 2. So you can see that quadrant 1, quadrant 2, quadrant 3, quadrant 4, and you just repeat the circle. So that's how they end up with a sine graph, just by going around the circle and get the value of x and the y, and just plot the points. Okay, so this is a sine theta. And you're going to do the same thing for the cosine. Now cosine is horizontal, right? So once you follow that, the graph is going to look. So cosine, you end up looks like this. So here it would be a 0. So cosine is going to be started on the top, whereas the sine starts at the origin. Okay, so the cosine is going to start on the top, because look at this circle over here. So over here at 0 degree, cosine, remember cosine is horizontal, right? So at this point, the horizontal is 1, right? At 0 degree, the cosine is 1, and so therefore it's 1, right? And over here, when the degree is 90 degree, cosine is horizontal, so it would be 0. Okay, so that's why it's 0. Okay, and then you do the same thing with the tangent graph. So tangent theta, okay. Again, so tangent is a slope. Okay, so at 0 degree, the slope is 0. At 45 degrees, the slope is 1. Okay, and at 90 degrees, the slope is undefined. So for undefined, you're going to get the asymptotes. Okay. So all these are asymptotes. And the way to do your tangent is that you kind of go through like this. Okay. So every cycle. So each cycle is pi. Okay, and this would be your origin. Okay, this would be your origin right over here. Okay, so you have the sine theta. So sine, and this is your cosine, and this is your tangent. Okay. Now to do the other three, you just flip everything upside down. Okay. So for example, secant. Okay, the reciprocal of sine is cosecant. Okay. So to find the cosecant, so cosecant theta, okay, the red one, all you have to just flip everything over. So over here is 0, so 1 over 0 will give you the asymptote. Okay, I'm going to use this one here. Okay, so again 0, right? Sine theta at 0 degree is 0. So 1 over 0, when you flip it over, it will give you the asymptote. Okay, so over here again, here just 0. So when you flip it over, it will give you the asymptote. Over here 0, right? This value is 0. So 1 over 0 will give you the asymptote. Okay, over here 1 over 0 will give you that. Okay, the asymptote. And after that, you just flip this over because over here is 1. So 1 over 1 is still 1, right? So you're going to get that. Okay. So the red one would be the cosecant. And you do the same thing with the secant. Okay. So for secant theta graph, again, you just flip everything over. So 1 over 0 would be the asymptote, right? So here be your asymptotes. So the dashed line is the asymptote, which is that you're not allowed to touch. Okay? The graph will never touch the asymptote. And they can just flip this over. So whenever you're going to do the secant graph, just go and grab the cosine first and then flip it over. That would be the easiest way to do it. Okay. Okay. Now, for the tangent, it's kind of, if I do the flipping, actually it's kind of more confusing. So for cotangent, I'm not going to do on the same graph. Okay, I'm going to do it below it. Okay. So over here again, over here is 0, right? So 1 over 0 will give the asymptote. Okay. Now asymptote is infinity, so 1 over infinity will give you 0. So I'm going to do all the asymptotes first. Okay. So again, I'm lining it up so it helps you to see. Okay. And over here, notice over here the value is really high, right? Okay, so over here is infinity. So when you flip it over, 1 over infinity will give you 0 right over here. 1 over infinity will give you 0. Okay. Now next thing is the graph is going to go this way. Okay. Because as it approach to 0, like 0.111, like 0.000001, 1 over that will give you really high value, right? And over here, as it approaches infinity, it's going to approach to 0. Okay, so again, 1 over like a million is going to give you small value, so therefore it's very close to 0. Okay. And notice over here, the origin is right over here. Okay, for the tangent graph, the origin is right over here. For the cotangent, the origin is right on the dashed line. Okay? So those are kind of the graph of 6 different functions. Then after that, you kind of have to deal with the things like amplitude, shift, and so forth. Okay? So normally when you have a function, when you have like a f of x will equal to k plus a sine of bx plus c. Okay. So the k is your vertical shift. this is your amplitude. And this will determine the period. This controls the period. This is not the period itself. So period equal to 2 pi over b. Okay? And this is your horizontal shift. So the shift would be equal to negative c over b. So those are the everything that you're going to see in the function. Okay. There's another word you need to know, the frequency. Okay, the frequency equal to 1 over period, and so therefore equal to b over 2 pi. Okay, so let's go and look at example 4. Let's go to page 17 and look at example 4. Example 2-4. It says determine the period, amplitude, phase shift, and frequency of f of x equal to 3 sine of 4x plus pi plus 7. Usually, to avoid confusion, normally you don't want to put plus 7 in the back. This is your k. Normally you want to put in the front. Okay. Okay. So let's go and answer each one. Okay. To determine the period. So here's your k. That's your a. That's your b. That's your c. Okay. So to find the period will be equal to 2 pi over b. So period equal to 2 pi over 4. Okay, so period equal to pi over 2. So that's the first one. The amplitude is this one over here. So A is equal to 3. Now this is absolute value. Okay, it just shows how much it deviates from your center line. So even if it's a negative, if it is a negative, means the graph is flipped upside down. But the amplitude, it will still how much it varies from how much it deviates from the center will be still the same. So this is absolute value of this number. Okay, so it's always positive. So amplitude is 3. Now the phase shift. So the shift is equal to negative c over b. So the shift will equal to negative pi over negative c over b. So negative pi over 4. Okay. And then what's the next one? The frequency. Okay. Well, the frequency is 1 over pi. 1 over period, 1 over p. So the frequency would be 2 over pi. Okay, just reciprocal of that. Okay. Okay, let's take care of that. Okay, let's go to example 2-5. So you're giving this graph over here, and it goes like this. And this is negative 5, positive 5, and this is negative 2, and this is 3, and this is 6 over here. Okay. So it says find the frequency. So you're looking for the frequency, you're looking for the period, and you're looking for the amplitude. Okay. Okay, now to find the amplitude, what you need to do is first you need to find the total height. Okay. So this is going to be the 7, right? So this whole thing over here is 7. So your center line is going to be right over here. So the amplitude will be equal to 7 over 2. Okay. So it's going to be fun. It's going to go up 7 over 2, go down 7 over 2, give you a total of 7 over 2. So amplitude is 3.5. Okay. Next one is, let's go and find the period. So notice so period is how often it repeats itself. So notice it's 3, 6, right? So it takes 3 to repeat itself. So period equal to 3, and the frequency will be just reciprocal of that. So frequency will be 1 over 3. Okay, and that's it. Okay.